Do you need also some power over there? We could, why not plug one in here? Ah, here. So, that should help here. Thank you very much. You're welcome. Thank you. Morning. Good morning, everybody. Sorry for those who came early. I think we owe you a beer sometime, so in the evening when we are finished. But Janis will make it up. So for the installation it will be fine. Today we are coming to the second risk factor, which is counterparties. So here, so we have been describing contracts. So the contracts contain the hardwired rules. So contract contains what can be considered a fact in finance, a hard fact, because it's a promise, and the promise once given is given and known. Markets, we have discussed. We said we know the current state, but we don't know the future state. So it's a risk factor, but one which is at least known well in its present form. Now we come to counterparties. So the same applies in counterparties. So there's something known about counterparties now, but how they evolve over time, that is less known. But even the now known things in counterparties are less known. For example, if you have a yield curve you almost can consider like a fact, though it's already quite derived from bond prices and a lot of assumptions. But this we can consider to be some truth as we see it. Now, how is it with ratings? Now, ratings, even the ones we know today, are more subjective. We know how the ratings came from Standard & Poor's, those who should know best. But there are also internal ratings of banks, and so they always try to do as good a job as they can, but it's much less good than like having a yield curve. It's much less factual, so you have more surprise. But still, there is a current rating, and the current rating we can take as a fact. So that's the thing which we need to take into calculation. And then again, the future rating, of course, we do not know, therefore it is a risk factor. So, and linked to counterparties is the notion of credit risk. So that is linked to market risk, and counterparties is closely linked to credit risk. One counterparty can own one or several contracts. So you have one contract or many contracts. And of course, a contract is a pattern of promises. And the idea is that the counterparty does honor and pledge the contract, but we know it's not always true. Even if the counterparty is not the crook, even if the intention is to pay, sometimes you cannot pay because circumstances drive it in a way where it's impossible to pay. Important is the notion of collateral and guarantee, all these kind of things. So the counterparty can have a contract with you which reduces the risk. which is a guarantee. So somebody else is guaranteeing, so that is mitigating the risk. And collaterals and guarantees are also contracts. So a collateral is also a contract, is also a fact. A guarantee is also a contract, is also a fact. But of course, even sometimes guarantees can be broken. That can happen. In counterparties, we have one part which we could call a descriptive part. So describing a counterparty, the characteristics of a counterparty. And then we have a modeling part. Modeling within RiskPro, this happens within the behavior part. So we have a modeling part, we have a descriptive part. So the descriptive part describes the current status of the counterparty. So what kind of characteristics do we have? If it's a single counterparty, of course it's a name, it's probably an age, marital status, and all that. So all information which could help you to figure out the creditworthiness of the person. That's the idea of it. If it's a firm, it's often turnover, profits of the last few years, etc., etc. So also trying to establish the power of the firm. If models to derive ratings often have 4 or 5 factors, that's all. That's normally with 4 or 5 characteristics. You can get very close to expected default. Or said otherwise, if you add more and more information, you don't get much closer. So these models are often quite simple, only a few observations. So then we also have hierarchies, because counterparties, they are linked to each other. Like a holding has children, or has children, or parent-child relationship. So like IBM has maybe some subsidiary, and giving a loan to this subsidiary is somehow linked to IBM. So IBM could even be the guarantor, depending how that relationship works, or at least it's in the background. And at any rate, if you give a loan to the subsidiary and to IBM, then you are, especially in both cases, you are exposed to IBM. So the risk gets a special profile. So hierarchies are important elements as a part of the counterparty risk. So, and then, of course, there are links to financial contracts. Actually, it's the other way around. On each contract, you will find a link to a counterparty. So there is the it's called, I think called, Janis, it's still called CP ID, or what is the attribute in RiskPro? The link to counterparty? There's something like counterparty ID or CP ID or something like that. So that's a really very important attribute. That's because that links then each contract to the correct counterparty. And then finally we have the credit enhancements. So credit enhancements are guarantees, collateral, closeout nettings. These are the 3 ways of doing credit enhancement. So that's all needed. A lot of that is needed to describe, to find the rating of a certain counterparty. And then we come to the behavioral, the statistical, or the modeling part of counterparty risk, of credit risk. So very important, of course, is the probability of default. So that derives from the rating. So you have characteristics, ratings, probability of default. So that's how it goes. So that describes how likely are going to default. But when you default, normally not everything is lost. So something is to be recaptured, to got back. So we have recovery rates. So how much are we going to recover? But then recovery is not recovery. So there are different ways how you can recover. For example, if you would get, let's say, the person defaults and you get right away the money, that's one way of doing it. Or you get the money over years, that's another way. So the value is quite different. So maybe you saw that in the discussion with Greece now. So the people only, the banks, I think they had to give up something like 50% of the notional. Now that looks like losing half. But banks lost about 70%. Why? Because they had the lower rates, and so they get the money very late, and they push it into the future. So they will get the last money maybe in 30 years. So all that is the difference between 50% and 30% value. Although the notional is only 50% written down, but the real net present value is 70% written down. So the real cut they take is 70%. Why did they only settle then for 50%? I mean notionally. Why didn't they just go straight for 70? Somebody has a clue? The difference is the bookkeeping. So if you write down the notional by 50%, so you only take a hit of 50% today. So if you would do it on net present value, they would have taken a hit of 70%, and that's probably a difference of about 20 billion euro or something, or 20, 30 billion euro. So you don't have to take that hit now, but that's pure bookkeeping. But it's still important, because that's then how they are judged. So the recovery patterns are important, and there is a fourth element called used at default. Used at default has to do with credit lines. So if you give a credit line to a certain person or institution, then they have the right to draw. And the experience shows if somebody defaults, shortly before the default, people try to save themselves by using that credit line. So if you have an open credit line, even not used, but if that counterpart is going to default, you must already consider now that the lot will be used. You cannot stop it. You will not recognize it. So part of the default will be drawing of the credit line. So all this is part of the modeling which we do and which you can do using the software here. So our discussion now, actually I only loaded the newest slides a little bit late last evening. So if those who have taken the slides in the morning might have a little bit be out of step with those slides, but you can download, I think, the newest version right now, it's there. What we want to calculate is the loss. So how much of the promised cash flows are we not to get? That's the task, what we have. And we do that in 3 steps. These are also the 3 steps which came up with Basel II. By the way, it's always clear if what I say Basel II, because I heard once somebody thought it's the farm team of Basel, you know, the second team. So it's not the second team of Basel, it's the Basel regulation, and it has to do with the Bank for International Settlement, which is, has its seat in Basel. But you hear Basel all over the place, even in China. If you are somewhere in a bank, you hear China, and in between always Basel, 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 then you always know. Yeah, I asked once the people in China, where is Basel? Didn't know it. So didn't know it's in Switzerland. So I was a little bit sad. So, okay. So that follows Basel. But it's a good way to think about credit risk, and RiskPro is closely built like this. Not exactly, I will mention where the difference is, but it's a good grid to think about credit risk. So it gives you a good mindset here. So first, we have to calculate what is called exposure at default. So exposure at default is the amount which can be lost. So how much can I lose if somebody defaults? That's the first step, because that is at danger. Then the second is loss given default. So when we have a default, how much are we really going to lose? Because there is the recovery process yet. So not everything is lost if it's defaulted. And the third is then the expected loss. So we multiply that with a probability, so because that is, up to now it was loss when we have default, so assuming it's a default. Now we assume that no, it's not, it's 100% guaranteed that somebody is going to default. If that would be given, you would never have given the loan at the beginning. So there is only a certain probability that somebody is defaulting, and so then you get expected loss. In each of these steps, we have a different data quality. And therefore, they should be kept separate. It's very bad to mingle those steps, because you have very good quality data, things which you can measure quite objectively, and then the other things which are getting more and more esoteric, more and more estimation and unsure. So that's why it's important to keep them separate. What happens in reality, they are often mixed, especially rating agency mix steps. So they mix often credit exposure and recovery rates and ratings. A good case was the CDOs, subprime stuff, where you could miraculously make top-grade instruments from a very lousy underlying instrument. That was the trick applied. It didn't work out at the end of the day. I think it was a disaster. But it shows also how bad it is to mix all these things together. So it's very important to keep them separate in your brain first, but also banks should keep them separate in their systems. And of course, finally, the rating agencies should also separate it. But that, I think, takes a while, because there are some habits of thinking. So, and if you have that, then the PDs which we have in the last step should reflect uncollateralized junior debt. I will come back to that. So we do step 1, exposure at default. So how do we get exposure at default? So, and you must consider now that in the system you have already all the contracts. The contracts we were discussing 2 lectures ago, the financial contracts. So they're all there. So they exist. So we start with the notion of gross uncollateralized exposure. That is basically all the assets a bank has outstanding against a single counterparty. Or it could be also a hierarchy of counterparties here. So that's the total exposed value. Of that, of course, right from beginning, not everything is lost, because we have what we call credit enhancements. So credit enhancements are items that mitigate the exposure. One simple mitigation could be you have some liabilities. Let's say you have loans from a bank, at the same time you have a saving account with that bank. So if the bank would have the right to take the saving account when you default on the loan, then the default is already less. The bank might not always have that right, so the things could be separate. But there are cases where this happens. So this is what is a credit enhancement. There could be other things, like a very classical case you have in mortgages. So where is the collateral of the mortgage? Yeah, exactly. So there's always, and that's why it's such a good contract. So the bank can always go to the house, sell it, and then it's covered. So then the exposure is very small, maybe 0. Normally it should be 0 because they only give you 80% max, at least in Switzerland. In other countries maybe you get some more. But here I think at least they want to have 20%, you have to bring your capital But still that could shrink because market value of the house can change and then suddenly it's less value. If you have these credit enhancements here, so the total exposed value minus the credit enhancement, this is exposure at default. There are, however, different notions about recovery. We said then loss given default would be then this exposure of default minus net recovery gives loss given default. That's the formula we saw before here. But with recovery, we have already some confusion. There is a concept called net recovery and another gross recovery. Net recovery works, first we take off all the credit enhancements, so everything which we can deduct by guarantee. So we have the exposure at default, and then from that we recover. We still recover something of that because maybe there's something to be gained. Gross recovery includes the credit enhancement, so it's like in one step. So that's this kind of mingling. Why is it not good to mingle? Because credit enhancements here, they can be measured as data. Not 100% exact. For example, you have a house as a collateral. Of course, you don't know exactly the value of the house, but you know pretty much. You know a lot, actually. If you know there is a house, so you have already very good knowledge. And you should not approximate that knowledge with an average number, average statistical number, which you got maybe from measuring whole Switzerland or something like that, the total recovery. So those things should be measured as they are, as house, with its current value. And then only from the rest, we should go and make an estimation. Because recovery rates are always very rough estimation. So you look a little bit in the market and say, okay, in average we recover 30%. Okay, that's quite an average number because it's a statistical number. So the quality of recovery data is already much weaker than credit enhancement data if you can have that. That's why we shouldn't. But we have to keep both concepts in parallel. And I think, Yanis, it's also still kept in parallel in RISPRO, right? There's still gross and net recovery. So you have to be careful what you're doing. And whenever you can, you should work with credit enhancement and net recovery. Yeah, so there is also something about exposure and valuation. The question is here, if you say exposed value, what do we mean by value? Do we mean the book value? Do we mean the net present value? And logically, we should take the net present value, because that is the most close value to economic reality. That's the difference between writing off the 50% or 70% in terms of the just written off Greek debt. So the 20%, because one is measured in market value terms and the other one is measured in notional terms, book value terms here. So we have to be careful when we do valuation, when we talk about this concept, which valuation we do take. So within RISPRO you can take any valuation, but you always have to know what you're doing. And of course, in the background, if you do your own calculation, you should always at least consider the net present value or market value. That should be there. Now, even if we have the exposure here today, let's say we net present value a certain exposure, this exposure can change over time. And I think I forgot to include that graphic here, but you find a graphic in the book where we run a Monte Carlo simulation of a certain exposure. Because some exposures are quite market dependent. That's not so much for a bond. Even a bond, of course, the bond changes its value if it's market dependent, but it's always not too far from 100, plus minus 10%, maybe 20% in the worst case, normally. But if you have part of your exposure is a swap, the value of a swap can swing in any direction, so it can go from positive to negative, and it can multiply X times. Especially if you have a fresh swap in your book, the value is basically zero, should be close to zero if you have made a reasonable deal. Then the value of the swap should be zero. Now, then that can go to plus 100 or 1,000 or whatever, and that's of course X times, million times the initial value which you have. So there you have to be very careful, and what you have to do is to have expected exposure. So you have to run a Monte Carlo scenario, which it's described in the book. Actually, I have to include next time a slide here as well. But I think it's easy to imagine how it happens. You take that exposure, you run market scenarios. The market scenarios change the value of this, actually of the credit enhancement of the exposure. So you get a net exposure depending on the market scenarios. And if you have many scenarios, you get, let's say, a value distribution over time. And then you can take, for example, the 95 upper limit of that, for example, or 99% upper limit, and take that as exposure, which would be then greater as the current exposure. So taking the future into account. So that has also to do with haircuts. Probably have you heard about haircuts? I mean, not your, also that one, but haircuts and add-ons. So these are two mechanisms which are heavily used. They're also described actually in the book. And the haircuts basically are based on such a Monte Carlo simulation. Whether the Monte Carlo really has happened or not, maybe it's a belly Monte Carlo, something that they imagine that the value can change. And sometimes it happens also with rules, like they have in Basel certain rules, like if you have a swap of, let's say, longer than 5 years, then you must include maybe 20% of the notion of the swap. Because that is about what we know from experience, so much a swap could swing. So we have to add 20% of the notional of the swap to the exposure. Another part for cross exposure is the counterparty and the hierarchy itself. So first of all, the counterparty, we have a unique ID. So this unique ID you find on each financial contract. You will see that when you work with contracts. So there is an ID. That's the most important. There's more counterparty-related information, but that's the one. So once you have set that one, it's linked well with the rest of the world. And then there is, of course, additional information as we discussed it already. And then the hierarchy. And then the assets outstanding per hierarchy. Not only the assets, also the collaterals, the guarantees, everything. And then, if you have that, and that's you must see, once you have contracts, you have the counterparties and you have the links. You have a very powerful system. So it links all. So then the system can understand exposure, and it can understand it at different level. For example, it can understand it at that level. That includes everything below here. Or it can understand it here. Or it can also understand that the collateral is linked to a counterparty, or a collateral can be linked to a contract. That's a difference. If it's linked to a counterparty, so it covers all the contracts below. If it's linked to a contract, it covers that contract. That happens often, for example, if a firm is already in dire need and they still need additional credit, then the bank will say, yes, I will give you credit, but only on that contract and collateralized with that contract. So I need collateral on that contract, so that becomes like a small counterparty. So, and you express that inside RiskPro by linking the contract either to a contract or a counterparty. There are even more tricky things like, if you have 2 or 3 counterparties, guaranteeing one thing and so on. So so you can do a lot of things. But once you have set up the data correctly, it's there. So the links, the logics, you find inside the system. You can check it whether it's right. And maybe you find an error. So they will be thankful for you if you do that. Yeah, between gross exposure and net exposure, we have what we call the credit enhancements. So this is an overview of on the credit enhancements. So we have two types. One you could call counterparty-based, people-based, and the other one asset-based. And of course, even if it's people-based, behind them finally are also assets. So you only can guarantee if you yourself have assets or some power to fulfill that guarantee. Very important contract is the guarantee itself. And you will see in RiskPro that is a contract type of its own standing here. So that is a person or a firm saying, I guarantee a loan. And then we have things like credit derivative, like constant default obligation, CDOs and stuff like that. But that's the same, actually. It was like AIG standing there. Actually, it was an insurance. It was an insurance. So AIG came as the guarantor for these subprimes, for example. So it's, of course, more standardized, etc., etc. But then it's a credit derivative, and it has certain rules when it kicks in, like if something defaults. Now, the big question again, if we take the Greek case, did they default? Did they not default? That has to do with that, because in one case, those guarantors have to pay, and in the other case, they don't have to pay. That's the question then. The others are the asset-based credit enhancements, so where you directly have an asset. So one is then called collateral. So these are like you give a bond. And so a bond is actually financial collateral, and the physical collateral would be a house, so a mortgage. And if you have houses inside RiskPro, you model it as a commodity. It's a commodity contract, by the way. And then finally, you have closeout nettings. Closeout nettings is if you have a contract with a counterparty that you can take in, say, liabilities in the case where assets default. That's the saving case. So you have a saving account plus a loan, and you have the right, the bank has the right to cover itself with the saving account if that is the case. So that is linked then on the contract level. Just for you, how that is handled inside the RiskPro data. So guarantee is a real special contract type. It's called GUR, I think, or something like that. Yeah, GUR. So that's it. Now this, did you implement already credit CDOs? No. Okay. This one doesn't exist, but the underlying of the credit derivative is again a guarantee, actually. It's a little bit the higher order guarantee. So what you have to model it with, you have to model it with guarantees if you do credit derivatives. And you get somehow approximated to the effect to it, because it's not yet implemented. Collaterals are themselves normal contracts. So collateral, if it's a bond, it's also a PAM, principal at maturity. So you model that like any other contract, because it has cash flows and you have to evaluate it, etc. So why do you have to evaluate the collaterals? Because, of course, your net exposure depends on it. Let's say you could have so much exposure and the value of the collateral is so much, so your net exposure is so. But if now the value of the collateral increases, your net exposure decreases, and the other way it increases. So that's why it's very good to have, first of all, to understand your collateral already like normal financial contract, so you can evaluate them, etc., like the same. But the difference is, as long as there is no default, the collateral does not affect you directly. It doesn't create income, it doesn't create cash flow, nothing at all. It only creates cash flow in the case of default. So it takes a special role in that here. And so that's why we model it like normal financial contract, like it would be something on your book, but there is an attribute on the contract which is called contract role. So contract role defines, normally it's standard is, how do we call it, on balance sheet or something like that? What is? There's a standard role, the default, which is it's on the balance sheet or it's an off-balance sheet item, so it's active. Or the other one is then collateral, COL. So then the system will know, oh, I have to use it differently. It's only there in case when something is defaulting, then it will kick in and create the cash flow. That's how it's handled. And then closeout nettings. There is closeout nettings, there's again a special attribute on the contract which defines a closeout netting and actually the contract number. If you have a closeout netting with somebody, it's like a contract, so you number those contracts, closeout netting contracts. And all which have the same number are within the same closeout netting. So they will be, in a case of default, taken together, and you see what you lose net. So it has an effect on your exposure. Yeah, that's basically what I have been saying right now. Yes, I mentioned already guarantee as a special contract type. The guarantee itself is the underlying of the credit derivatives. And actually, guarantees, if you really look at them, they are non-life insurance products. Actually, they are nothing else than an insurance. That maybe makes it understandable why AIG was so big in them. But the sad thing is, they took it like an income source, probably didn't make any reserves for it, which is, of course, quite disastrous. At the end, it cost the government, I think, $150 billion. A rule for guarantee and guarantors is that the guarantor must have a higher rating than the obligor. The obligor is the one which gets the guarantee. That is one of the rules also for Basel II, for example. So that a guarantor can only be a guarantor if the guarantor has a higher rating than the obligor. And what happens if you have a guarantee? Basically, you move the exposure from this person to that. That's all what you do. Huh? So suddenly you're exposed to that higher rated guarantor, which reduces, of course, your risk, because there's a higher rating. But imagine now when the whole world moves all the credit risk to one firm, AIG. So highly exposed. There's only a little movement, then can make big disastrous results. Yes, credit default swaps are just standardized guarantees. And there is the possibility of double default. So you can default, okay, that's fine, you have a guarantor. Okay, the guarantor will pay, but the guarantor might default as well. But of course, the probability is much smaller. It's basically if they are independent, it's just the multiplication of the two probability of default, so it becomes pretty small. It's still a very good system. Credit lines, just to complicate the case even more. So there is a contract type called credit line, CRL. You will find that in RiskPro. So credit line gives you an amount where you can draw. Say that's the whole credit line. So much you can totally draw. But you have drawn so much. So you have still an undrawn part here. And of the drawn part, a part can be collateralized. So maybe some credit lines have already a collateral linked to the credit line. So only that is uncollateralized. But of that undrawn part, we said, if you think about credit risk, we also have to consider that quite a part of that will be drawn in case of default. Because people will use that, because that's the fastest money you will get. So you're in trouble and you try to save yourself. Okay, get as much money from where you can get. And if it's too late, then that will be part of the mass of default. So that's why how it's calculated. So you take the credit line, you take the exposure, and then you take the potential, so you still can have that, so much open facility, and then you calculate the potential drawn part of it, which then finally gives you the total exposure. So that's all preparatory work just to get the exposure at default. But within the system, it's all setting up the right data. So the links are there, so because once you have the data, of course, there's a lot of calculation happening in the background. It has to know all the relationship, netting, etc., etc. So that happens automatically. Next step is then loss given default. So that we consider that from the thing we lose, still something we regain. And here we are on net, not on gross recovery, net recovery. One thing yet, in reality, actually, we have here as a second step, loss given default. The reality happens a little bit different. Actually, you have exposure first, then you have the default, and then the recovery. That's also how actually RiskPro works internal. But I follow the other way of Basel, because for Basel it doesn't matter really, because they don't have a structural model. They only take the net number, so it's a pure multiplication, and A times B equal B times A, so it doesn't matter whether you do it this way or that way in their calculation. In RiskPro we have a real structural model, so we have to do things in the right sequence. So it's happening like that. For an argument's sake, it doesn't matter. So we look at recovery, so gross recovery. We said we don't want to do that. So we talk about net recovery, so about this part here. And net recovery is described by two steps. One is the recovery rate, and the other one is the recovery pattern. Because it's not the same if you recover and get all the money right now, or if you recover and get it over long terms, over the next 30 years. They're two entirely different stories. Also value-wise, in every respect, very, very different. And these two steps have to be described. Recovery rates, normally they are based on simple historical experience. I haven't seen anything better yet. Maybe there is. But basically you take a look at all the banks in Switzerland, you look at the default, you look at how much has been recovered, and take that ratio, roughly speaking. Yep. So it ends up in a simple percentage number, so that's also what you normally enter into the system. And then you have recovery pattern. So we had originally, say, these cash flows here, not this one, that's a new one, but these were the original cash flows. Somebody defaulted here, so these cash flows go. And then they are substituted with a recovery cash flow. And there are different patterns. So this pattern is like a one-shot pattern, so you get it back after one period. So here you define the percentage and the time between here and here. basically. That's what you have to define. Or you get it something like that. So here you define also the timing and the size over time. So and there I think about 3-4 main patterns, because there's no use to be very precise. So it's good if you estimate like one shot and over time. I think there's 3 or 4 patterns where things are gained back. So the last step is expected loss. So we know now how much are we going to lose. And so we have to multiply that with probability of default, which we will do after the break. Those who have something to install, maybe it's a good time now to do the installation. Is that possible, Yanis? Very good, thank you. Okay, it looks like you're ready, and we anyway have little time. So I would like to start with the third part, expected loss. So that's the final step to calculate expected loss. So loss is closely related to rating, which is described by descriptive data about counterparties. There is also something which is called scoring. Scoring is observing people, how they really pay. For example, if you go somewhere, especially like in countries like Germany and Switzerland, it's a bit more tricky, but in Germany, so if you buy something and you don't pay, that will go to a database. And then you are marked. And then your credit rating drops drastically. And it's also a very good indicator. So if you give a loan to somebody who hasn't paid the last five bills, you are likely not to be paid in your own bill as well. So credit scoring is widely used to judge counterparties. So that's by observed payment behavior. In Switzerland, it's the Betreibungsamt, which has a similar thing, but it's more complicated than in other countries. So ratings are often external, but there are also internal ratings. So because many firms then where you neither have a scoring nor external rating, so you do your internal rating. And of course, rating agency didn't do a good job, so especially because they were too much dependent, and they have to become more independent. From a conceptual viewpoint, the pitfalls in credit rating is especially by mixing the notion of collateral and rating. Often a rating includes the notion of collateral. So, for example, there's a rating for Credit Suisse, but then there's a rating for a special part of Credit Suisse because it's somehow collateralized. That makes it, again, very fuzzy, very unclear. It would be much better to have that the rating would only describe the probability that something defaults. That would be actually the best. And that's the same like the rating you find on uncollateralized junior debt. This again has to do with the idea that you should not mix highly statistical data with facts which you can know better. So the probability of default is something quite subjective. It's statistical, as good as statistics can become, but the collateral is something which you can measure and which you can quite closely judge by value, etc. So, and by mixing two, you get a bad system. And if you take the uncollateralized junior debt, then rating corresponds to probability of default, or can be transformed into a probability of default. So ratings must finally turn into a probability of default, because rating is a letter, like AAA, AA, B, C, etc. So that doesn't help you yet. So you must have a link between the rating and the probability of the default. There are different ways to express that link between rating and probability of default. One is to express it as a scalar, as like one number. But that comes down to having like a single rating class. The second is a vector, and the third is a matrix called migration matrix. I'm starting with the migration matrix. So this would be, say, a classical migration matrix. We have three states, so rating A, B, C, and say D is default. So somebody is going to default. And the classical migration matrix looks as follows. So it has, as we see, here we have the diagonal, and all the big numbers are on the diagonal, because that describes how likely somebody who is A today is going to be A tomorrow, or A in 1 year. It always has a time horizon here. And how likely somebody A being today is becoming B, C, and default. So it has this notion, and we see that the diagonal is well occupied, and it has some characteristics. The sum over here must be 1. Of course, you're always in one of those states, so it must sum up to 1 here. And then the special thing here, down here, so if you're in the default state, so you are not assumed to come alive again. So that is that. So once you are in here. But what you also can, if you're B, you can also become still A. There's a little chance, eh? Yeah.
Do you think that there's going to be a change in how people create those matrices, given the recent event due to the bigger swings in the credit?
Yeah, I mean, not conceptually, I don't think, but judgmental, yes. You know, and finally, I think we will not be able to do without historical experience. In as much the historical experience probably will change the default probabilities. Yes, it surely has. Because that often depends on what you saw in the past. And now we saw some really bad cases. So A's going into D. That's normally, often here was 0, actually. So in this sense, it will change. But conceptually, I don't know. I haven't seen anything. Have you seen something? No. I think it's difficult. They're difficult to find a better technique. So, but once you have that, so this has a certain horizon. So if you multiply those matrices over time, so you get let's say this is a 1 year horizon. That's the states where you are in likely in 1 year. And if you multiply the matrix, so that's the state in 2 years, in 3 years, etc. So you can, by multiplication, you can find out now the expected default in the future. That's also how RISPRO works, mainly internally. So this is the migration matrix. There is a simplified version of it. That's actually the vector version, where you, in this case, basically it's sufficient to store this one here, because the rest is on the diagonal. That means you only have 2 states. You are either what you are or you're dead. So but that's a simplification. I think using a full migration matrix gives you a better expression of how things move over time. So that's the 2 ways you can express it. So now we have a probability that we are going into default, and we have already the recoveries, everything. So we have the old cash flows, the new cash flows, and the probability that we will be in the old state and in the new state here. Once we have that, everything else again will be affected. It will affect, and here these are the analysis elements, so the lower elements of our famous picture. So of course it will affect liquidity. My cash flow streams will change drastically. So those streams will be substituted with that. But it will have an effect on value. We have a new set of cash flows, then including probabilities, and of course an income, drastical effect on income, because you have to write off all these cash flows and then substitute it with something new. But what we can see here, if we know everything about the cash flows and the events, this is a logical derivation. So it follows very logical what happens afterwards. Just a few specific items yet. CDOs is there's an originator which collects different mortgages, puts it into a pool, and the pool is then cut into pieces and is then sold to other people. Here. And what the rating was, because we have now a lot of, let's say, C-rated assets, and we put them into one pool, and we say there is a certain fraction which loses first, is equity. Then junior debt, they are the next to lose. We don't know who is losing, who is defaulting, but whatever the first is goes into that. The second, they go into that, the mezzanine, and then into senior. The problem was that this tranche up here had 85%. So after this, all the rest was 15%. And of course, that was then depleted quite fast. I think we have now 10 million houses in default. So they ate into this tranche here. Of course, makes it tricky again to model. So in RiskPro, we don't have the contract type yet. I mean, it's tricky. It's a lot of work. You have to organize the data internally that the first loss goes to here and here and here. But that will come, but not as long as you are using it. Finally, there's credit limit. That is an entirely different thing. So credit limit, it has to do with the control of credit risk, but itself it's another concept. So what you try with credit limits is to keep the exposure small. You say, for example, nobody is allowed to have more than X% of my equity. So if my equity is 100 and the X is, let's say, 7, so then nobody is allowed to have a net exposure higher than 7. So you take that as a limit and you have to browse all your net exposure. So now you're going to calculate all the net exposure, check every net exposure against this value of 7, and then you can see whether this is exposed or not. This is counterparty based. There are other exposures like industry based. So that's another way to diversify your portfolio. It's also a way to limit actually credit risk, because if you have everything in one industry, then you are highly correlated. That means if the industry goes bad, all your loans are going bad, or a lot of your loans are going bad. So what you try is to spread the risk factors, the credit risk factors, by putting it to different industries. So you say each industry is not allowed to have Y%. And then you can do the same by region. That's another way to diversify, and you can do it by risk factor. Say, should not be more exposed to US dollar in such an amount, to this currency in such an amount, to this interest rate in this way, and to that. So you have a whole set of rules, which once you have every single contract, they are easy to check. You just group the contracts, the exposures by rule. And you measure against the limit, and then you can see whether you have surpassed it or not. So much to credit risk.